Doubling the fundamental. A musical novice learns that doubling the fundamental increases the pitch by 1 octave and decides to do that to a guitar string. What factor increase in tension would be necessary? Do you think this would be a good idea? Now, we're talking about waves on a string. So for mechanical waves on a string, the propagation speed of these waves is basically related to the tension on the string and the mass per unit length, square root of tension, T is tension, and mu, the mass per unit length of the string. Mass per unit length. So if we consider a guitar string, we can see that the two ends are fixed. So when we form standing waves on this guitar string, these two ends must be nodes. So we have the fixed boundary conditions here. So the normal modes that would be generated on a guitar string would have a fundamental node, antinode node, second harmonic or first overtone, node, antinode, node, antinode, node, etc. And for the fundamental node, antinode, node, we have half a wavelength between two nodes, consecutive nodes. So L, the length of the string, would be equal to the wavelength lambda 1 divided by 2. For the second harmonic, it would be equal to a full wavelength because we have a distance from one node to the consecutive node of lambda over 2. And we can see that the wavelength lambda n for the nth harmonic would be given by 2L divided by n. So n is equal to 1 is lambda 1 is equal to 2L, lambda 2 is equal to L, so we have 2 here, 2's cancel, etc. So this n is 1, 2, 3. And the frequency Fn times lambda n is equal to the propagation speed v. Therefore, we see that the frequency of the nth harmonic would be given by n divided by 2L, which is 1 over lambda, multiplied with the propagation speed, square root tension divided by the mass per unit length, and this is the frequency we would like to double. So we will get a pitch 1 octave higher. Okay, so we can see that since the frequency varies with tension as square root of the tension T, with all the other factors fixed, to double the fundamental frequency, we would need to have tension T becoming 4T. So T must be quadrupled. That's what we see. So that means we have a factor of 4 increase in tension is necessary in order to go 1 octave higher in the fundamental frequency. All right. Now, is this a good idea or not? So if you increase the tension 4 times, we're going to have a very high tension on that string. So this high tension will probably damage the string. So Doing this is not a good idea. We may be causing an irreversible damage on the guitar string. Okay, so we have a musical novice who learns that doubling the fundamental increases the pitch by 1 octave. So in order to double the fundamental on a given guitar string, what factor increase in tension is necessary? So we can play with the tension on the string and try to get 1 octave higher by increasing the tension. So first of all, the propagation speed is square root tension divided by mass per unit length. And when we consider a guitar string, the boundary condition is that we have two fixed ends, so two nodes. And the fundamental mode is node, anti-node, node, which has a wavelength of 2L. The second harmonic has a wavelength of L, etc. The wavelengths are 2L divided by N, where N is an integer, 1, 2, 3. The corresponding frequency times the wavelength is the propagation speed, is N over 2L, which is 1 over lambda, times square root T over mu. So if we are keeping the fundamental mode, so N is equal to 1, length is not changing, mass per unit length is not changing. The only way to change the frequency is by changing the tension. So to change the fundamental frequency, which is proportional to square root of tension by a factor of 2, we need an increase with a factor of 4 increase in tension. But this is a very high tension that will probably damage the string, so therefore this is not a good idea.